All right, good morning, everyone. We're going to give a minute or two for people to start filtering in, but I want to thank you guys for joining us this morning. This is the second round of the Analytica ICP Alley webinar series. So if you're not familiar, Analytica is next week in Columbus. So I hope you'll join us there if you are in the area. If you are in the area and still need a ticket or anything, let us know because we have some free passes that are still available. So if you want to go to the show for free, just shoot us an email, make a comment. Our team will reach out to you. And you can visit ICP Alley at Analytica US in Columbus, Ohio next week. So I think it's going to be a really exciting show. So today we have a really good webinar for you guys. We're bringing back the ICP Alley team. So first off, Alicia from CEM is going to give a quick presentation on some pre-digestion topics. And then she's going to hand it over to Mike from GFS Chemicals, who's going to talk about measuring blanks to help find contamination. And then Randy from Glass Expansion is going to talk to you all about some common nebulizer issues. And then I'll finish out the day with some talk about how to measure near the limits of detection. So, a really good summary of some really good tips and tricks for ICP analysis. So, you'll get a good introduction to all of the ICP Alley folks. And again, if you're in Columbus next week, please stop by and see us. We're all going to be located in a block around booth 1400. So if you go there, you'll see all four vendors. Stop by and see us. You can collect plasma passes if you talk to each one of us, and you can turn those in for a really cool toolkit, or you can stop by, get a coffee, recharge your phone. We'll be near the front entrances, so we should be easy to spot. Well, with that, I'm going to kick things off and hand it over to Alicia for the first presentation of the morning. So, Alicia, if you'll take it away from here.
Okay, thank you. Let me share my screen. Okay, so appreciate the opportunity to participate in this webinar today. Getting excited about ICP Alley next week at Analytica USA. So we'll be talking about some tips and tricks here for sample preparation, particularly for microwave digestion with a focus on pre-digestion. That's what I'll be covering today. So let's get started with that. So why do you need pre-digestion? Well, pre-digestion is going to allow those gases, basically from that organic content in that sample, to release prior to capping the vessel. And this is going to allow us to have less pressure during the actual microwave digestion step. And all of that comes together so that we're going to have less excess venting, and then we're not going to lose potentially your sample or your analytes. So we'll be talking through examples of different types of pre-digestion that you can do that's going to help aid in having the best digestion possible. So first is we're going to talk about pre-digestion at room temperature. So this is going to be for those samples that are going to react as soon as you add basically that acid into that sample. So we've got a quick little video here, and I think it'll be very clear kind of the benefits of what you can get here. So as soon as you add the acid into that open vessel, you start seeing these gases release. Okay, so if that's going to occur right away, then you know that you just can do pre-digestion at room temperature. You want to allow this to occur for about 15 minutes, and then you can cap your vessel and move forward with your digestion. And again, that's just going to aid in a more efficient digestion where you don't have all of this excess pressure and you don't have any concerns of losing that sample and your analytes. Now, what do you do if you don't have a sample that is going to react like we just saw, but may present a temperature pressure curve like you see here? So you put it in, you see this kind of exothermic reaction occur where you've got a spike in temperature, right? We don't necessarily want to see that in our temperature pressure curve. So that's going to be a situation where you want to do a heat assisted pre-digestion. So let's talk through a specific sample where that would be the case. And in this case, we're going to talk about raw honey. So we've got this raw honey sample, and what we want to do is we need to first get our sample into our vessel. And the best way to do that is to warm that honey. If we warm that up, it's going to be more fluid. We can easily get it into our sample, or into our vessel rather, and we want it at the bottom of that vessel, right? We don't want it all over the sides and so forth. We want our sample nice and neat at the bottom of our vessel. And if we heat that up, we're going to be able to do that. Once we have our vessel, our sample in our vessel, we're then going to want to put that vessel in either a hot water bath or hot block and heat it to approximately 95 to 100 degrees C to allow that pre-digestion to occur. And here you see some of the examples of what that would look like, right? So very similar to that video that we saw at the very beginning for the no heat pre-digestion. This is just a sample that's going to need a little bit more heat to help aid in that pre-digestion to occur. And so again, you want to let this sit for around 15 minutes prior to moving to microwave digestion. And now, if we look at our temperature pressure curves, we go from having that exothermic spike to now having a really nice linear rise to our temperature, which is what we want to see. And that's going to aid in the most efficient digestion. So I've got one more situation to talk about as far as pre-digestion is concerned. And that's going to be where you have a sample that maybe has two different sample matrix types within it. So in this case, we're going to talk about a fish oil capsule, right? So we've got the capsule, which is some, sort of material, kind of gel-like material, and then you've got your actual fish oil in the center there. So what we want to do here is use an acid combination that is going to help dissolve that capsule so that we can then effectively digest the fish oil at the end of the day. And so at the similar concepts here, we're going to put the acid in, we're going to let that sit during our pre-digestion for around 15 minutes, and then we can move on to our microwave digestion. And so as noted, in this case, you need to think a little bit about that acid combination. So we're going to use a little bit of peroxide with nitric acid to help actually dissolve that gelatin capsule that we have. And again, this is just going to allow for better control of the reaction during the microwave digestion, because if you can imagine, we don't want that fish oil to be released into a pressurized hot acid, right? That's going to cause an exothermic reaction that we don't want to see. So that really is all of my tips for pre-digestion, which is kind of what we wanted to cover here today. We're excited to see you at ICP Alley while at Analytica USA. While there, if you come to the CEM booth, you'll be able to see the equipment you see here. If I kind of go from left to right here, we've got our blade system and then our Mars 6. Those are the systems you would use for microwave digestion. Then we've got our Oracle system, which is a fat analyzer, and it has a robot for high throughput situations. And then we've got our Phoenix Black, which is an ashing system. So we have a lot of options for you beyond just microwave digestion. And we don't want to leave you without any resources to reach out if you've got any more questions. So definitely, you can always go to our website at www.cem.com, or you can reach out directly to our elemental team, elemental support, at cem.com. Inorganic Ventures has an amazing interactive periodic table. So we always like to make a note of that. CEM also has some resources regarding the periodic table and what acids to use as well. We've got in our lab videos, right? We just covered some pre-digestion here. Lots of tips and tricks we can go over. So go over if you got more questions or want to see more tips and tricks, you can look at our inner lab videos. But again, CEM booth 1402, Analytica USA next week, and ICP Alley. And thank you very much for your attention. And I am going to pass it over to Mike for the next presentation. Thank you.
Thanks, Alicia. Before we move on, I want to highlight that there is a Q&A box down at the bottom of your Zoom screen. Please leave any questions there for any of us, and we'll either address them here at the end of the webinar, or if there's any run over, we'll get those back to everybody. So we'll pull up my screen to share. All right. Is this presenting my screen? Did I get that all in there?
Not yet.
Oh, no, there we go. All right. So I'm one of the quality managers here at GFS Chemicals. And today we're going to talk about the importance of a clean blank and all the benefits it can provide you. So when we are talking about a blank, what goes into that? You're obviously going to think about, an acid and water, getting high purity of both, generally an order of magnitude below what you think your detection limit in is best, to make sure that you're not pre-limiting yourself based on what you think you have. You always want to strive for better than what you need, just in case that you are ever asked to go beyond your limits. But the number one thing that isn't thought about is making sure that you have clean and prepared vials. If they're plastic, that means leaching the plastic with some acid. And then beyond the vials, anything that you're having this solution touch or your samples are touching is also another thing to make sure that you're cleaning and leaching well, to make sure that you're not getting pieces of contamination there. Um, every method's going to have a blank because it helps validate your method, to make sure that, yes, your instrument, your methodology can produce zero results for everything that you're testing and saying that it is, that it's not, your method's not artificially contaminating it, and you're handing out false positives and false high results to your customers or whoever's looking for those results. So it's vital to have lower detection limits, vital to have low background so that you're getting the most accurate answers. But the blank can also be a great tool for identifying and finding and solving contamination problems that you may have. And it's vital to and challenging to keep this blank clean, because every time you're exposing your vials, your chemicals, your acid, your water, your sample, you're opening up situations where you may be contaminating your sample or your blank. So it's vital to keep making new and clean solutions as much as you can. When you go to look at your results and they're all jumbled up and covered up by a background, you will often want to go in search of contamination. So when you want to go remove that background, you're going to want to start isolating different parts of your process. Start by just running your blank, verifying that your instrument in blank can produce a zero result before putting it through your method. This will involve possibly isolating your acid and your water in separate steps. And whenever possible, try and have a second source of acid, either a different lot or different manufacturer. Same with your water. Most people are going to have an in-house water purifying system. Not the worst idea to purchase in some ultra pure water, just to make sure that that's on the same standard that everything else is going to be running at. And you want to do this all one step at a time. Even if it's the middle step, isolate that one step to make sure whatever new components may be added in that step can get accounted for. Maybe you're grinding up a sample or using a different type of tube, or something that's not the same as your end result, that's not carried all the way through. Isolate those by running your blank through it as well. And I think that's one of the things, particularly if you're homogenizing something, grinding it up, something that people are not always thinking about. Yeah, I should rinse my blank through this to make sure that it's not picking up contamination and contaminating my sample itself. And a lot of times it will. CEM, I know in some of their presentations will talk about the use of different types of homogenization tools, depending on what elements you're looking at. And sometimes you're going to use that blank and what you pick up there as a blank correction. And you may have more than one spot where you're looking at that contamination, where that image we saw before, say we found one piece of contamination, but we're still left with this. There's still some background there. That's an indication that you're going to need to find multiple places that you may have your contamination. One of the real key things that we use in our lab, that we use our blank for, is something that we call process fingerprinting. And that's kind of the basic process that I've outlined here, where you should isolate different materials in your lab, whether it's an vial made out of HDPE, and then one made out of FEP, one made out of quartz, and get profiles that your instrument can measure from each of those isolated. Because in general, each material and manufacturing of a type of material will give different ratios of contamination from different elements. One might give you 2 parts aluminum, 1 part calcium, 6 parts sodium, whereas the next plastic may give you 1 part aluminum, 1 part potassium, 1 part sodium. And it's best to learn what contamination levels and ratios are going to come from common things in your lab. This one here, we've looked at gloves. Everybody's going to be using them. They are all a major source of contamination for all sorts of elements, as you can see here. Um, Even if you guys are working in the parts per billion, these values are in parts per trillion, but they're getting up into the double and triple digit parts per billion just from glove contact. These are all pre-rinsed, or these are all gloves before they've been rinsed. These numbers all drop by about a factor of 10 once you rinse them. So I encourage people, rinse your gloves as another big tip, particularly when making your blank and prepping your samples, something that's going to be going into everything. And trust is everything. You need to be able to trust your blank. You need to be able to trust your instrument. That's why we start with those when we're trying to find sources of contamination. And then be vigilant about cleaning your lab and labware. That if you're not constantly cleaning those, particularly those plastics, they're going to pick up and store contamination, even if you think they're clean. That it's going to be a constant battle to make sure that you can get the best blanks that you have. And then when you buy in materials, verify what you're getting. When you purchase a bottle of acid or whatever, it's going to come with a C of A. The C of A is not performed on every bottle. It is often representative of dozens, hundreds, or even thousands of bottles. Uh, Protect yourself. Make sure you know what you're getting when you receive it into your lab as best as possible. And even once you have verified that, continue to verify that bottle as much as you can reasonably, because every time you sample from it, every time you open that bottle, you're opening it to chances of exposure, and making a good blank that you trust and verify is one of the best ways to be able to constantly verify and check that the materials you're getting, the solutions you're using, that they're all staying contamination free. So if anybody has any questions, feel free to reach out to me. We will be at ICP Alley as well. They're at Analytica. So leave us any questions. And then I believe I'm handing this off to Randy to talk about nebulizers.
Thanks, Mike. Just get my screen up here. All right, can everybody see the presentation? Yep, looks like we're good to go. All right, well, thanks for joining us this morning, everyone. My name's Randy Mercurio. I'm the ICP Technical Specialist at Glass Expansion. And please visit us at Analytica if you're going. We're at booth 1400. And let's jump right into solving the most common nebulizer inquiries that we receive. A quick webinar outline. We're going to talk about how to select a nebulizer and some important criteria to consider when you're choosing a nebulizer. We'll go over some unique design features of Glass Expansion's nebulizers, and we'll go through some steps to identify nebulizer issues and challenges that you may face in your lab. And then we'll talk about some tips for proper maintenance and care of your nebulizer. And we'll go over a few tools and accessories that can help improve the performance of your instrument and also care for your products. So when choosing a nebulizer, there's a few things to consider. There's many factors. This is an overview of Glass Expansion's nebulizer line. One thing to consider is total dissolved solids. Like what percent salts or dissolved things are inside your samples is important to consider. Another important thing to consider are particulates. If your samples have micron-sized particulates in them, you may help choose a nebulizer by deciding on that factor as well. We also have another tool to help eliminate most particulates, and we'll talk about that shortly. If you're running hydrofluoric acid in your samples, you don't want to use quartz or glass. You're going to go to an inert line of nebulizers at that point. And this is your Opal Mist, Duramist, and V-Spray, and this is a PFA nebulizer, a PEEK, and ceramic. In some cases, you might have a boron low detection limit. In that case, you'd want to run with quartz, which isn't going to have a lot of boron in the background like the glass nebulizer here. So this is an example of a back pressure chart for a glass expansion nebulizer. At 1 liter per minute, which is the optimum gas flow for this particular nebulizer, you're going to get 40 psi of back pressure. And this is typical for all glass expansion nebulizers where you're going to want to see a 40 psi reading. This particular nebulizer is an Agilent nebulizer at 0.4 mils per minute. And it tells you the argon gas reading here in the middle number. So that's the 1 liter per minute there. Glass expansions nebulizers have unique design. They have a lot of unique features, such as this vitricone sample channel, which is a thick-walled glass capillary that's precisely milled. And we also have a unique UniFit sample connector, which allows the capillary tubing to directly transfer the sample right into the glass milled capillary without any dead volume. And then as opposed to other designs where they have these thin fragile capillaries, and you can see there's a region here where there might be some dead volume, and it takes a while to wash out these regions, and there's also a place for particulates to collect. So we just learned that glass expansion nebulizers are best at 40 psi, but what should you do should your nebulizer be reading at a higher level or a lower level? So the first thing to do is when you get a new nebulizer is to warm up your instrument with that nebulizer and then record a benchmark back pressure reading for that nebulizer. Should you see a low nebulizer back pressure and a loss of sensitivity, it could indicate that you have an argon gas connection problem. There could be a leak in there. So you're going to want to inspect the nebulizer gas arm, and you can check the connection at the instrument to make sure it's secure as well. There's a chance that the nebulizer could have some damage, and you can inspect it with the magnifier inspection tool like this to check the tip and the back of the nebulizer to make sure there's no particulates collecting there. High nebulizer back pressure can indicate a partially clogged or blocked nebulizer. And you're going to want to either clean the nebulizer or replace it with a new one if you have one handy and you need to get up running quickly. These are our LUO tools to help back flush nebulizers when there's clogs, and we'll talk quickly more about that in a minute. And you also should record your normal sample uptake rate, because a change in your uptake rate can indicate a blockage, worn pump tubing, or incorrect tension on the pump. So with low back pressure, again, you should inspect the nebulizer for damage. Make sure that your gas connections are sealed properly and not leaking. For high back pressure, you should clean the nebulizer because there's a good chance you have a clog. And the LUO is a great device to use to backflush all GE nebulizers. So how to take care of your nebulizer on a day-to-day basis. When you start and finish a run, you should be using a mild acidic blank solution and followed by a rinse with DI water for about 5 to 10 minutes. And what this does is it just prevents salt deposits from forming inside the nebulizer when the solvent dries out. So for blockages, what you want to do is initially flush the nebulizer with water using the LUO, and then you can soak the tip in a 25% Fluca for 24 hours. And you may have to initially use the LUO to get the Fluca within the nebulizer to wet all the surfaces. And then you can just flush that out with water 3 times using the LUO. And if you still see some stubborn deposits, you can soak it for 2 hours in a 5% nitric and then just flush that again with 3 times of water using the LUO. If you want to get up and running quickly, it's useful to use something like methanol to flush through the nebulizer, and then you can let it dry in your fume hood quickly to get it back in the instrument. So this is Glass Expansion's Guardian inline particle filter here. And what it does is it prevents large particles from clogging your nebulizer. And it's basically inserted, you splice the capillary in between the probe and the nebulizer, and you insert this filter. It's a reusable peak filter, and inside the filter block here is 120 micron pores. And then you can easily backflush this using our LUO. A lot of labs will do it daily. Some will do it once a week, depending on your sample load and types of samples you're running. We also have a Guardian auto sampler probe, and this has a robust ceramic tip, and it eliminates crushed or damaged tips should the armature become misaligned and hit a cup or something like that. And it's also drip resistant, so it prevents cross-contamination. And it also has this built-in particle filtering. You can see these pores here in the tip of the probe. And that prevents any large particulates from getting up into your sample introduction system. There's a peak sheath here at the top of the probe, which helps make sure it's aligned with each vial every time. And we offer interchangeable UniFit sample lines here that can come in the different sizes you see here. These are the IDs. And we also offer this probe for many different auto samplers, from the Agilent SPS series to the Thermo ISC65. If you see a lot of salt deposit on your injector or perhaps on the tip of your nebulizer, it might be time for an argon humidifier. And what this does is it takes the gas supply from your instrument in through the Allegra, and it goes through this membrane here and humidifies the argon gas, which is initially really dry. And then it continues on to the nebulizer, and it'll prevent those salt deposits from forming at the tip of your nebulizer and also at the tip of your injector. This can help prolong maintenance periods and helps solve problems like analytical drift. The Easy Glide cloth is a great tool to use if you're looking to reduce the friction between your pump rollers and your pump tubing. And basically what it does is it increases the service life of the pump tubing by just reducing the friction. We also have the TrueFlow, which is a great way to monitor your sample flow on a routine basis while you're running. So it's a real-time analysis tool that comes with some software. And you can set a set window where you don't want the sample to go below or above a certain flow rate. And this will set an alarm for you so you can be aware of any clog forming, for example. So in summary, what did we learn? The first thing is to record your back pressure on your nebulizer. When you get a new nebulizer, warm up your instrument and record that benchmark value. Then you'll know how to assess the low nebulizer back pressure. And you'll also know what to do when you have a high back pressure. In the example of low back pressure, you're going to check your gas connections and inspect for any damage on your nebulizer using the magnifier inspection tool. And if you get a block in your nebulizer with a high back pressure, you can clean the nebulizer using our LUO tools. There's lots of different tools available and accessories that can help you analyze your sample. Sorry about that. Go back. And these are all available to help these types of challenges that you might receive or experience in your lab. The Glass Expansion has a fully equipped R&D laboratory with a lot of expert technical staff, and our website is chock full of great things like application notes and newsletters to instructional videos and webinars. So if you'd like a free review of your sample introduction system, please feel free to reach out to us at GEUSA@geicp.com, and we can optimize your sample introduction system components or try and go over any challenges you might be having in your lab. We can even explore ways to reduce your operating costs and identify other performance enhancing accessories that might be suitable for any challenges you have in your lab. We're also able to make some custom quotes for you if you like. Well, thanks for your attention today. And we have offices throughout the world, so we can service your company if it's global. And please feel free to reach out to us at geUSA@geicp.com with any technical questions. We look forward to seeing you at Analytica this year. And if there are any questions about the stuff I covered today, please put them in the questions box below. And I'm going to hand it off to Mike Booth now. Thanks, Mike.
Awesome. Thanks, Randy. Well, yeah, like Randy said, if you have any questions at all about any of the presentations, please enter them into the Q&A box at the bottom. We will take questions and have all the presenters go through the answers right after this presentation. So without delay, I will start sharing my screen here, and we will go through the last presentation of today, talking about how to measure, or some tips for how to measure at the near the limits of detection. All right, so first, I think it's kind of good to just review, this is not the textbook definitions. A lot of the material I'm going to cover today is more kind of rule of thumb, not worrying so much about, the exact textbook definition or the exact, significant figures that we're going to use in some of the examples we cover later on. But sort of a rough rule of thumb is for a limit of detection, you're looking at 3 times the signal to noise ratio. So if your sample has a signal to noise ratio greater than 3, you can confidently say that you detect that element of interest present in your sample. Limit of quantification is similar, but it's increased. So you see more signal. So in that case, you want your signal to noise ratio to hopefully be above or greater than 10. If at that level, you can say confidently there is this analyte present, and you have a really good shot of taking a very good measurement on it with a pretty good uncertainty. So measuring near the limit of detection is difficult because you just don't have a lot of signal to work with. Um, the way that I always look at it is I look at the raw instrument signal and I pay attention. Typically, most folks are running calibration curves. So take a look at the calibration blank and use that kind of as your noise. And then take a look at the samples you want to measure and do that ratio conversion using the raw intensity or raw signal from your calibration blank as this noise. And that's kind of a rough way to calculate it. I would say pay close attention to your lowest calibration standard when you do this, because ideally you want your lowest calibration standard to at least be in that limit of quantification range. So 10 times that the signal on the lowest standard than what's present in your blank. So just wanted to define terms early on in this presentation. Really, the best way to measure near the detection limit is typically to try to not, because it's really hard to get accurate measurements. And I know that's kind of like, maybe a bummer on the whole presentation, but there are other ways you can get around it. So the best way to try to not and measure near the detection limit is to increase the signal. So there are a few things you can try. First up, just think about how little of your actual sample is hitting the plasma. So, if you're sampling a particular sample, whether it be a liquid or a solid material, there's some sort of either dilution or digestion that's happening. So can you increase the amount of actual sample that you're, introducing into the sample introduction system on the ICP? So can you modify your digestion to digest more sample? Can you modify your dilution factor to not be such a high dilution factor? That may or may not be an option depending on your sample type, right? Because sometimes, you know, you just can't digest enough sample to increase that. Um, so you may be limited on that, but that might be an option. Typically, the reason why you dilute out further is dilute out matrix effects, which we're going to talk about a little bit later in the example I'm going to show in a couple slides. Matrix effects can have a big impact, but honestly, with as good as the instruments are getting these days, it's easier to deal with matrix and effects and impacts than it is to try to measure near the limit of detection for a tough sample. So there's a lot of good options to measure in a difficult matrix. The next thing you can do to try to increase the signal is, can you change the instrument measurement settings or the conditions? So, you can always try to adjust the RF power. That's a good way to get, more signal out of it. But also look at your intro system components. There's a lot of different nebulizers you can use that can increase signal. You can look at your flow rates. I'm sure the team at Glass Expansion would be happy to help out with that, just to see, hey, what can you do to actually get more of the sample that's being aspirated? How can you get more of that sample into the plasma? Because when you work it out, it's very, very little sample that you even put on the auto sampler of your ICP mass spec. Most of that's getting, put through to waste out of the spray chamber. There's very, very little that actually goes into the plasma itself. And then lastly, you can try adding some additives. So 2% methanol has a good history of increasing the signal for some elements. I put a reference paper on there. It's pretty easy to find if you Google search that paper. I don't think it's paywalled. So it's a good read, but there are some other things you can do to try to increase the signal through additives as well. If you can't increase the signal, though, you can always try the opposite approach, which is lowering the blanks. So Mike from GFS went over, a lot of good information on this. I would always recommend higher purity acids. Can you just lower that background in any way possible, especially if you're measuring near the detection limits? Try to use higher purity acids. Watch out for contamination. We talked a lot about this 2 weeks ago in our first Analytica ICP Alley webinar. So if you weren't there for that one, please go back and check out the recording. There's a ton of good information about contamination in that one. And then I would also say focus on taking really precise measurements. You'll never get really good RSDs of your blanks, like not as good as you get for an actual sample or, a calibration standard where there is that element of interest present in your sample. But can you get really good precision, and can you transfer that into the blanks as well? Because that can help out a lot with measuring near the limits of detection. So that might be changing out the sample intro system, looking at the flow rates of your instrument, looking at different accessories instead of introducing sample through a peristaltic pump, using a syringe drive, something like that. If you're really measuring near these limits of detection often, try focusing on how to take very precise measurements at low concentrations. And again, you'll never get low RSDs in your blank, but maybe you can get lower RSDs than you're getting currently. So I'm going to go through an example. This is something that came across actually within the past month or so. A sample came in our lab that we were testing. And for us, this is really important for us to get a good idea of impurities that are present in different materials. So we're measuring nickel on mass 60. We ran a calibration curve. We ran a sample through, and you can see the table that's highlighted here. We ran a blank before we ran our calibration standards that are highlighted in blue. We ran another blank to test for, what elements might have washout issues, make sure we got everything washed out before we introduced the sample. And then the sample plus spike that we ran are highlighted there in purple. So this was in a matrix. This sample had a really high concentration of total dissolved solids, just a lot of different materials that probably in the tens of thousands of ppm, if not higher than that, concentration in the sample itself. So we diluted quite a bit to get that material out of the matrix, but we still have a really high total dissolved solids concentration. So we ran using matrix match calibration standards, and this is the data that we came out with. So this sample you can see the counts on it are extremely low. The RSD on it is pretty high, but if you just ran it through the calibration curve, it's going to give a result of 0.063 ppb. But again, when you look at the RSDs on that sample, you look at what's the signal to noise ratio on that sample compared to our calibration blank, it's not great. It's not even 3 times the signal to noise. So one of the things you can do is spike in more of your analyte of interest to increase that signal and then subtract that result out. So we spiked into that sample 1 ppb of nickel and also ran that sample plus spike on the calibration curve as well. So you can see that's the last row in that table there. Our counts went way up, right? We've added more nickel to the solution, so we're getting more signal. But look at that RSD. That RSD is way lower. It's a much more precise measurement. So taking that sample plus spike intensity of about 5,700 counts, 5,800 counts, running it through the calibration curve, that comes out with a result of 1.005 ppb. So we correct that by subtracting the amount of nickel that we spiked in, which was 1 ppb, and that returns a result of roughly 0.005 ppb. So much different than the 0.063 ppb that if we just ran the sample through initially. Um, I would say, for us, it was really important to try to get a really accurate number on this nickel contamination present in this material. The real number is probably a lot closer to that, 0.005 ppb than it is to 0.063 ppb. It's still not, we can't give a really good uncertainty on it. I can't say it's, that number within 1%, but I have a strong feeling that that is a much better number than 0.063 ppb. So adding that spiking in so you can get higher signal, more precise measurements is definitely a good way to go. All right, so more resources for you guys. This webinar series is really great because we get a lot of people together and cover a wide range of topics. If you're looking for more resources or tips and tricks, check out our weekly podcast that we put out every Tuesday. I'll especially highlight the tech support Q&A episodes. Those are regularly sort of scattered into it. It gives us a chance to discuss a lot of real world questions, sample types and techniques and methods. So definitely check out Bench Boost if you haven't, if you're not aware of that. Also, our annual ICP conference is coming up next month. It's going to be held October 14th through 16th at our facility in Christiansburg, Virginia. So there's 3 days of lectures and hands-on lab work. So if you are interested in that, please let us know because seats are limited and they are filling up very quickly. So if you're interested in that, please reach out to us and let us know. So lastly, again, this whole thing was around Analytica. So if you are attending Analytica next week, please stop by and see us. If you're in the area, like I mentioned, and need passes, please reach out to us. We have some passes for you guys to go attend the show for free. Definitely stop by ICP Alley. We have a coffee bar, a charging station if you need to recharge your phone. The ICP Alley Challenge, that's what I mentioned at the beginning of the webinar. Stop by, collect a little pass from all 4 of us, and you can turn that into an ICP, or you can turn that in for an ICP toolkit, which is really cool. And I think the most important thing is, though, you can meet one-on-one with us, with all of the vendors. Bring pretty much any question you have between the folks at Inorganic Ventures, Glass Expansion, GFS Chemicals, and CEM. We can probably give you a really good answer. It's a really good opportunity. If you have questions, please stop by and see us because we have a wealth of resources and experience to help you guys out. We did this at PitCon earlier in the year. It was a big success. So yeah, hopefully we'll see you next week. All right. So I'm going to stop sharing the screen. We have a poll that's going up. Will you be attending Analytica? Yes or no? If you want to take that real quick, we hope to see you there. But I'm going to move into the questions. So if you have a question, please feel free to enter it. We're going to answer some of the questions live here. So enter it in that Q&A box, but I am going to go through the questions, and the first one is for Alicia. So this person says, this is from Renee in Indonesia. They work for a food laboratory where the samples I analyze come from various types of matrices. Do you have any tips to prevent venting from happening? With different types of matrices being digested in a single process using the Mars 6 microwave, is it possible to estimate the lifetime of the turntable?
Yeah, thank you. Some great questions there. So to cover the kind of mixed samples on a Mars 6 to prevent venting, really at the end of the day, best practice is to run like samples, right? So if you're running a batch of like samples, that is going to lend yourself for the best case scenario. But I understand specifically in the food world, that may not be possible because you are running so many different types of matrix types. So if you're doing that, you want to make sure your samples are well balanced on your turntable. Okay. You don't want all of one sample type to be one side and then all of the other sample type or other different sample type on the other side. Make sure that they're evenly balanced throughout the turntable, and that's going to lend yourself for the most evenly heating and less venting as you go through that process. But it's always going to be more challenging when you're running mixed samples. To move on to the kind of lifetime of the turntable, I'll honestly say that probably more so concerned about the lifetime of your vessels. I'm going to assume maybe you're using express vessels. If you're using express vessels, you really want to be inspecting those, make sure you're not seeing a color change or stretching, or they're not fitting as well in your liners anymore. Those are going to be signs that you maybe need to replace your vessels. We also have some rules of thumb for the turntable as well, but that's going to be so dependent on your method. What temperature are you running? How long? What your actual samples are and what your vessels are. So certainly we can have a further conversation here. So I encourage you to reach out to our elemental team, elemental.support@cem.com, because we certainly can provide more information regarding this question. But thank you.
Awesome, thanks. Alicia, I have another question here for you. They say that I use nitric acid and hydrogen peroxide in digestion. How do I know if our samples are effectively digested at room temperature? Is a steady temperature rise the primary way to verify a successful digestion? Thank you.
Okay, so the whole thing I covered was pre-digestion. Okay, so you're not going to get a full digestion at room temperature. What you're looking for is to really gas off that organic content in your sample, so that that's going to be taken care of prior to then running your microwave digestion, where you're going to get your full digestion in your elemental content. So really, a rule of thumb of when that pre-digestion is done is when you're not seeing those gases come off anymore. You saw how exothermic that reaction was, right? It's quite visible. So as long as that's slowed down and it's really not occurring anymore, you've probably done it long enough to go ahead, cap your vessel, and move on to your digestion.
Awesome, thanks. Next question I have here is for Randy. Randy, you mentioned the argon humidifier in your presentation. Can you run us through any maintenance that's required for that?
Sure. It's a pretty low maintenance device. Basically, it's a matter of making sure that the water's filled appropriately to the lines that are on the inside container. There's a membrane inside, which is really the only thing that gets changed every so often. So if you take care of it, replace the water frequently, and don't let it sit for extended periods of time with the water in it, it's really maintenance free, other than just keeping that fresh water in there and making sure it doesn't get algae or anything building up inside. But otherwise, it's pretty much runs for quite some time before you need any parts or anything like that for it.
Awesome. All right. Next one I have here is for Mike. What vials do you recommend for standards and samples, and what brand and what should they be made of? Should they always soak them first, no matter what they are?
So it's going to very much depend on what your detection limits are. Sometimes an HDPE vial is going to be just fine for you. In our lab, we're typically using some sort of Teflon or quartz vials for your highest purity stuff. In general, if you are using some sort of HDPE or Teflon vials, yes, I would always soak those before use in some sort of dilute acid, and then rinsing them with some higher purity water before use. And you should be using the same vials for your standards as your samples, so that you're not getting any different levels of contamination in one versus the other. Try and keep that as uh, the same as possible. As for brand, I mean, there's a lot of good brands out there. Ours, for our Teflon vials, we use Civilix. They were very convenient for what we are using. And then we've also had some custom-made quartz vials. So the type is going to really be dictated based on the level of detection limits you're working with. If you're working with something really 1 ppb or below, I would suggest trying to look in a Teflon range. They are very reusable, and good cleaning techniques can keep them a long life.
Awesome, thanks. Alicia, I got another one for you. Are there any tips for pre-digestion of the samples that start to foam and can actually overflow the tube if left open to the air before digestion?
Okay, so first thoughts there are maybe we need to reduce that sample size or run in a larger vessel. We do have a wide variety of different sizes of our express vessels. So again, I'm not sure what you're using here. So that's just my first thoughts, but I definitely would encourage you again to reach out to elemental.support@cem.com because so many of these questions are dependent on what your samples are running. So when we know what you're running, we certainly can give you much more information than that, acid, or I'm sure there's other things that could play into this as well, depending on exactly what we're talking about here as far as what sample you're running, the acid you're using, the volume, sample size, all of this comes into play. So
Awesome. All right. Randy, I've got one for you. It's in regards to the Fluka that you mentioned. Could you give more details on the 25% Fluka that was in your presentation slide?
Yeah, the Fluka is basically a concentrated cleaning solution, and you can dilute it down to different concentrations to clean. The 25% is really more of a higher level that we use for stubborn deposits and clogs and things, but lower concentrations can be used even in situ while running, say, for example, in an ICP OES, you could run a 0.5%, 1% to try and flush your system and then flush it out with some DI. It can replace like the mild acidic solution. But Inorganic Ventures also has the ICP True Rinse, which is a great way to flush out your system at the end of the day and then rinse it with some DI to get rid of any residual elements and sticky things that may be kind of adhering inside your sample introduction system. But the Fluka is really a good all-around kind of cleaning solution for spray chambers, torch components, and nebulizers. So it's really great for that. People like it.
Awesome. Thanks.
Yep.
All right. Alicia, I'm going to take it back to you for another one. If using nitric and HCl for microwave digestion, is it better to add both at the same time for pre-digestion or add them one at a time?
Yeah, so I'll be honest. I'm going to say I think we've got the information to reach out with more information later. I'm going to need to go to our elemental lab to see exactly what they're doing on this one because I'm not exactly sure. Anybody else in the panel knows, and I apologize for not knowing exactly the answer to this particular question.
I know I've always added them just one at a time. I don't know if I've ever made a mixture and added them together.
Yeah, that's my gut instinct as
Yeah.
well. But like I said, I'm actually not the one running it in lab, so I haven't actually prepared it. And so I want to make sure that I'm not saying something. But my instinct is exactly what Mike Booth just said. So.
Awesome. Thanks. Mike, I've got another one for you here. How often do you fingerprint the lab materials that you talked about in your presentation?
So anytime we get a new manufacturer or element, we run them through, and then periodically we actually just go and refresh our list. Usually trying to do one item or something a week, so that every 3 to 5 weeks or something like that, we've gone through almost every material that we have to make sure that nothing's changed from a manufacturing standpoint and that we're still getting consistently the same ratios and types of numbers that we historically get.
Awesome. Thanks. Alicia, back to you for this next one. How can we reduce wear and increase the lifespan of the equipment's metal parts? I believe that they mentioned microwave digestion, but I think that's for the microwave digesters.
Um, I guess I guess what equipment? I mean, our systems are, if you're using microwave digestion systems, there are, that's all protected, right? So you should have longevity and there shouldn't be any concerns with corrosion or anything like that, right? We've built in coatings and whatnot that are protecting that system for microwave digestion. And then as far as the pre-digestion is concerned, you need to make sure you're not interfacing with metal parts, right? So a lot of times you're making sure, I think it was discussed when you're weighing your samples, make sure you're not using metal spatulas, you're using Teflon coated spatulas. And, there's always different ways of like silica and, other types of materials that you can use beyond just metal. So avoiding metal parts is also very good.
Awesome. Thanks. All right. We got last couple questions in here. So this one came in for me. Often it's troublesome to analyze some elements such as lithium, sodium, fluoride, and potassium. Do you have any suggestions for this? Can you recommend any application notes or reports from industry? So I would say through ICP, fluoride especially is going to be very difficult to measure. I don't know. I've never had any luck measuring fluoride on ICP OES or ICP mass spec. I have heard recently, like within the past week, that there may be a new instrument model hitting the market from Perkin-Elmer that's I'd heard they're calling it a quad for ICP mass spec. And one of the selling points was to measure fluoride. So I would say investigate that if you're looking for ICP techniques to measure fluoride. Lithium, sodium, potassium, those are all easily ionizable elements. So those can have issues with them. You often get a lot of signal, so you're typically not measuring near your limits of detection for those elements, thankfully. But I know with lithium a lot, we get a lot of questions about lithium. I always recommend using an ionization buffer for OES on lithium. And typically, if you add 500 ppm of cesium to your samples and standards to matrix match, that will give a little bit better performance for lithium. Sodium, potassium, it doesn't do as much. I think sodium, it should help out with as well, that ionization buffer. But for those, you really just want to make sure you get the right concentration range. That would be my recommendation for those. They're easily ionizable. You typically can dilute those samples down pretty far and still get really good signal. So if you are not, measuring near the limit of linearity or where you're going to max out your detector, find a good concentration range, and then go from there. I'm not sure if there's any application notes or reports for those specifics. I would say also those elements are good to analyze on via ion chromatography. So you can do the cation ion chromatography for the lithium, sodium, potassium, and then fluoride via ion systems. So there are, good dual channel ion chromatography units that might be able to do both cation and anion at the same time. So I would recommend those. All right. Um, Randy, this one came in for you. What nebulizer should I use if we will analyze iodine and table salts? Any tips?
Yeah, depending on the TDS, it sounds like our sea spray would be the best model for that. Did they mention the instrument?
They did not.
Okay. Yeah, I mean, a sea spray, we have that for either ICP OES or ICP MS, depending on what type of instrument they're running. But yeah, the sea spray is great for salts. You might get away with our micro mist if the TDS is at or below 15%. If it's a little above that, you could go with the sea spray because that can handle up to 20% total dissolved solids.
Awesome. All right. And Alicia, I think you and I might be able to answer this last one about silicon. What is the limit for silicon to be digested with only nitric acid? What's the maximum that can be digested? So I'll let you take it, and then I have something to tack on at the end.
Okay, sounds good. So the reality is you are not going to fully digest silicon without the use of HF. So that's just the reality. If that's in your sample and you are looking for a full digestion of that, then you are going to need to add in, you're going to need some HF in your acid mixture. I will say often if that's not what you're looking for, you may be able to get fully, all the data you need for your application with a nitric acid digestion. So just it comes down to what you need at the end of the day. But if you need that accurate number for silicon, then I don't think nitric acid is going to be able to achieve that. So Mike, add on what you want to add on.
Yeah, sure. Yeah, I fully agree. You're going to need HF for silicon digestions. I will recommend check out our silicon sample preparation guide on our website. So our founder, Dr. Paul Gaines, wrote that one. It's really, really good. So if you go to the Inorganic Ventures website under the education tab, go to sample preparation guides. There's a whole document there about silicon sample prep. Has a lot of good information. So if you can't use, if your lab has a rule against HF, you might try using maybe tetrafluoroboric acid. That's sometimes a good way to get around things, but you're going to need fluoride in the matrix if you're working in an acidic environment to really get that silica in solution. All right. And we got one last question right at the end here. So Alicia, again, for you, any suggestions for fully digesting black mass from lithium ion battery waste?
Yep. Okay. Good question there. Really, at the end of the day, I think with black mass, it's going to be an acid leach that we're looking at, right? So we actually have an application note out where we did an in-process black mass sample. So you can go to our website and get that. You can see our data. We did a really good job of getting very accurate data and for the primary elements that you would be interested as far as reclaiming those metals and lithium ion batteries, but also for looking a lot at the potential contaminants that may be there as well. But at the end of the day, the reality is we are doing at this point an acid leach versus a full digestion of black mass for the applications that we've developed.
Awesome, thanks. Yeah, I know the carbon on those things is really difficult to try to do anything with. So yeah, leaching is probably the best approach. Awesome. Well, I want to thank you all for joining us this morning. I also want to thank our presenters. Lots of good information today. If you have any questions, please feel free to reach out. You will get a copy of the slides, and this webinar will be posted online. So if you ever want to go back and review, feel free to. But again, thank you so much for joining us this morning. Thank you to the presenters as well, and we hope to see you at Analytica next week. So thanks and have a fantastic day.
Thanks, Mike. Take
Yep,
care,
thanks,
everybody.
Mike.
Thank you.
Bye.